In our last science video, we learned that plasma is an energetic gas that has been ionized. At approximately 75 to 1,000 kilometers above the Earth's surface, the gas here receives enough solar radiation to become ionized and transition into that state. For several decades, it has been hypothesized that the magnetosphere and the ionosphere interact in such a way to create large looping structures of this plasma that follows the magnetic field lines about 600 kilometers up. In June 2015, this was shown to be true by a group in the Artz Center of Excellence for All-Sky Astrophysics, or CASTRO as it's abbreviated, and the School of Physics at the University of Sydney. The team used the Murchison Wide Field Array, a radio telescope spread out over 512 square meters in a circular pattern. The left and right half were able to operate independently. By using the telescope in stereoscopic mode, it was able to discern the depth of the plasma filaments above the Earth, and therefore track the three-dimensional movement of these structures. While it enlightens us to the invisible world above our heads, and provides us with an interesting visual, this research will go on to help other radio telescopes to reduce their error and improve their accuracy. This discovery was made by Cleo Loy, an undergraduate researcher working on her thesis. She won the 2015 Bach Prize of the Astronomical Society of Australia for her work. Her research may also provide a possible avenue for explaining how Whistler waves propagate within our atmosphere. Whistler waves are dissipated electromagnetic radiation from lightning strikes that propagate through the ionosphere. These plasma tubes could be acting as waveguides that allow this energy to be dissipated. However, that's purely speculative based on the information we have about the two topics. Be mindful that these structures are slightly lower than the Van Allen belts, which exist between 1,000 kilometers and 6,000 kilometers above our Earth. The two are unrelated, as Loy's observations were of high and low density tubes that extended from the ionosphere into the plasmasphere, where the neutral atmosphere of our Earth ends and transitions into the plasma of space. It is above this latter point where the Van Allen belts generally reside as a donut-shaped plasma soup that is held in place by our Earth's magnetic field. Continuing to research and understand these dynamic plasma waveguides within our atmosphere will continue to prove valuable as long as we use methodologies that require us to consider their existence. I hope that you found this enjoyable, and please stay safe. Know that you are incredible, and until next time, my witchlings, bye.